Hello, I'm Marcus Bedessee, and this is my presentation of my discussion of the Rootbeer simulation. So, what is bullwhip? The bullwhip effect is an occurrence in the supply chain that happens when small fluctuations in demand are magnified as demand increases and moves upstream the supply chain. The bullwhip effect can be caused by many things which influence demand, like a sale or a change in demand, such as with toilet paper at the beginning of the pandemic. Causes of the bullwhip effect. There are many causes to the bullwhip effect. Some of them include lack of communication, bad demand forecasts, no communication, pushing products, price fluctuations, and supply chain lags. So, onto the Rootbeer simulation. As stated previously, bullwhip can be caused by many factors, including lack of communication or no communication at all, along with price fluctuations and lags due to shipping. We play as the retailer, as shown on the right, the last line of the supply chain before the product reaches the customer. We are the farthest downstream the supply chain. According to the game, for each step in the supply chain, it takes about 2 weeks for an order to move for more beer to be received and processed by the next step, and about 2 weeks shipping time for the product to be delivered back, a total of 4 weeks from order to delivery. It is also mentioned that it is highly unusual for managers at one supply chain sector to talk to other managers in another supply chain sector, and in fact it is actively discouraged. So we've already established 2 different things that can cause the bullwhip effect before the game has even started. Those time lags for shipments, as well as the lack of communication throughout the supply chain, are some of the biggest factors. Bullwhip from the retailer's perspective. So as mentioned previously, we're the lowest member in the supply chain, the last line of the supply chain before the product reaches the customer. As a retailer, and being so low or downstream on the supply chain, we do not experience the bullwhip. We are the ones that cause the bullwhip effect on our suppliers. Price is also non-existent in this simulation, so there are no fluctuations in pricing. There's also no influences on the market that can change the pricing or any way to push or pull inventory out. There's also no way to change demand of the root beer. There is no clear way to experience bullwhip since we are at the lowest point in the supply chain, or see how the suppliers upstream the supply chain are dealing with the bullwhip. And with almost no fluctuation in demand, as I'll get to later, along with the inability to see the factory's production numbers based on our retail orders, it's difficult to illustrate how the bullwhip affected the supply chain, or if it even did. So here's a screenshot from my simulation. You can see from week 11 to the end of the simulation, I received absolutely 0 fluctuation in demand. Seeing that my simulation started in week 4, which means I had 7 weeks of fluctuating demand. To experience the bullwhip effect, there has to be a fluctuation or variance in the orders, as I stated previously, which mine clearly lacked. So, how to mitigate bullwhip? There are many ways to mitigate the bullwhip effect, and doing them in a combination with one another will help a company better mitigate rather than only implementing one of these methods. It is also important to note that it's almost impossible to completely eliminate bullwhip, but it's possible to reduce the effects and mitigate it. The cheapest and easiest way to mitigate bullwhip is just to communicate throughout the supply chain. This can be done with emails, meetings, or another form of communication. Communication helps with visibility and collaboration. However, this option is unlikely with current management since they actively discourage it, and is seen in this screenshot from the prepare screen. Since that option is most likely out, the next option is technological optimization. Technology can be used to optimize many supply chain processes such as managing supplier relationships, inventory management, and inventory planning. A good example of this is the implementation of an ERP system. ERP systems, or Enterprise Resource Planning Systems, can work with artificial intelligence, or AI, to help with supply chain processes so they flow smoother, which will help to mitigate bullwhip. However, some of these systems are very expensive. The next technique to minimize the effects of the bullwhip is inventory evaluation. This can be done in-house. This would include someone conducting routine evaluations and examinations to optimize the company's inventory. So similar to an ERP system, just done manually from within the company. as well as looking for ways to optimize the supply chain. This person would be a supply chain leader and be in charge of ensuring minimum and maximum inventory for root beer. A min and max amount of inventory will prevent ordering too much or ordering too late. The final common technique that can eliminate bullwhip is to reduce lead time and delays. As mentioned earlier, one of the root beer simulation's biggest hurdles and their major cause of the bullwhip effect is the time lead lag. It currently takes 4 weeks from when an order is made to when it is delivered. Currently, if the retailer or another member of the supply chain expects there to be an increase in demand, they have to plan an order 4 weeks ahead, which leads to the costs being accumulated due to having to store the product and such. My future recommendations for managers. My recommendation for future managers is quite simple. Just do your due diligence, your research, and understand what you are facing, how to avoid it, and what to do if it comes. So here's my emotions when I played the root beer game. The root beer game pulled on my many emotions. Before starting the game, I didn't really know what to expect. While playing the game, I started to feel stress and anxiety. Even though it was a simulation, I felt as if I was actually running the store kind of. And every step I made had a repercussion due to the costs I would face or the back orders of having my customers unsatisfied, or even having excess inventory and costing me a lot of money. Having a constant timer also made it difficult, as I did not have time to look for patterns and make a proper analysis. Instead, I had mere minutes to make my orders, which I would not receive for 4 weeks. I had to think very far ahead in the game in order to do well. So, my strategies and objectives. I like to think that I went over several strategies as the game progressed. As you can see here, shortly after starting the game, there was already a backlog since I had not ordered enough products. I know that inventory was only 50 cents per case if I had any remaining, whereas a backlog was $1 per case if I had any that wasn't shipped out. So at this point, seeing the erratic demand, I decided to order a large amount so I wouldn't go into backlogs, and that way it would be cheaper than having a backlog anyways. You can see here that in my weeks 11 to 17 that I'm making some larger orders and they're going to come in. Plus, I don't want to go into backlogs, so you can see once I ordered 175,000 cases. After I recovered from the backlog, I started ordering 100,000 cases a week roughly, from weeks 12 to 15, and then for some reason I expected a spike in sales since it seemed kind of steady, and wanted extra inventory on hand. From there you can see I noticed the customer is only ordering 100,000 cases per week, and sometimes less as I slowly drop my inventory. You can see that in the last 3 weeks I had 0 inventory, 0 backlog, and that gave me an ending cumulative cost of $1,387,500. Week 19, you can see I only received 75,000 cases as I downsized and I was trying to lower my inventory, which means in week 15 I changed my strategy and my behavior to try to get a better score. Do I think my strategy was successful? Well, I guess that's up to you to decide. There was positives and downsides to it for sure, but without anyone else to compare to, I'm not sure if my score would be good or not. I feel like I was successful since I avoided costly backlogs and did an okay job with the shipping lag times. But I was also unsuccessful because I think my costs were high and had a lot of excess inventory at certain points. Given another chance, I think I could score closer to 800,000. Here's a graph from my simulation showing my cumulative costs and how much each week cost me. You can see at week 19 where my inventory rapidly decreases in order to lower my cumulative costs, and by week 33 to 35 my costs were at 0. Looking at the cumulative costs, if I didn't spend weeks 1 to 4, which I had no control over, and weeks 15 to 19 with so much inventory, my costs would have been under $1 million. Here you can see my graphs for inventory and shipments. The one on the right for inventory doesn't show much or the full story since it only shows inventory and not backlogged cases that needed to be shipped out. The graph on the left shows shipments, both incoming and outgoing, in gray and yellow respectively. You can see a small bullwhip in outgoing orders that ends in week 10, leaving us with 25 weeks of the exact same demand. Here you can see my order and backlog graphs. Again, you can see the small bullwhip that ends at week 11 when the demand becomes constant and stops changing. You can also see how the spike of backlog spiked cases needed to be shipped out. To summarize what we've gone over, Blow-up is caused by a fluctuation in demand that is sent upstream the supply chain as the effects are magnified as it travels up. Blow-up can only be mitigated and not eliminated, and as we played as the retailer, the lowest point in the supply chain before the customer, we saw no fluctuations in demand from 25 of the 35 weeks in the simulation, and finally, communication within the supply chain will help. And with that, I'd like to conclude my presentation. Thank you for watching.